Let's take a look at some of these from section 5.3 and see what the period does for us. Okay, um, you correctly stated in 35 that, since there's a 1 right here, the period um, is 2 pi. This one with a 2 right there, this is 37, the period is, well, 2 pi divided by 2, because that's going to squeeze everything by a factor of 2 in the x direction. So that's just pi. Okay, now how does this help us draw the graph? Now, first of all, I got the impression from you that the pi over 6, you're okay with that was the shift. So rather than a sine curve starting at 0, I'm going to move over to pi over 6, which is a little bit more than a half. But the thing is, whatever it is, if I make my units here in equal lengths, each one pi over 6, this would be 1 pi over 6, this is 2 pi over 6, this is 3 pi over 6. Well, 3 pi over 6 is pi over 2, and there's 4 pi over 6, and 5 pi over 6, 6 pi over 6. Well, 6 pi over 6 is just pi, and then 7 pi over 6, and 8 pi over 6, and 9 pi over 6, 6, 7, 8, 9, 10 pi over 6, 11 pi over 6, 12 pi over 6, 12 pi over 6 is 2 pi. I'm going to go one more. It's a 13 pi over 6. And the reason I'm going over that far is because my sine curve, although normally it starts here since I'm shifting it over, likewise the normal end would be at pi over 2, sorry, at 2 pi, but it's being shifted over by pi over 6. Notice that if I take the pi over 6 and I add 2 pi to it, right, 2 pi is 12 pi over 6. So I got a common denominator. Now I'm up to 13 pi over 6. So that gets me my endpoint. So my start, the period gets me both started and ended at the same time. The shift gets me started, and the period then says, okay, now move over that much, and that's where the end will be. Starting here, the end is right there. Half the period, so if I take the period of 2 pi, and divide it by 2, that tells me where the halfway point is. So from the starting point, if I move over pi, everything's in terms of pi over 6s here, so this would be 6 pi over 6s. So 1, 2, 3, 4, 5, 6. Oh, right, pi plus, everything just moved over pi over 6. So this would be 7 pi over 6. That would be the midpoint of my sine curve. Right? Then if I take pi, my period of 2 pi and divide it by 4, so half and half again, that'd be pi over 2. So at pi over 2, halfway between here and here would be right there. But notice, this is 1 pi over 6, 2 pi over 6, 3 pi over 6 is actually pi over 2, and then I move another pi over 6 more, so that's 4 pi over 6. But that's where the sine curve is at its highest point, or at its lowest point. In this case, with the minus 2, it's at its lowest point. So if I'm down 1, 2 on the y direction, I'm there. And likewise, halfway in between here and there would be where I'd be up the amplitude of 2. So one cycle of that sine curve would look like this, starting at pi over 6, ending at 13 pi over 6. Notice the difference between those two is the period. Right? Over here now, where the period is pi, the shift is pi over 2 to the left. So if this is pi over 2 on the left side, this would be pi over 2 on the right side. Notice that here I was doing things in terms of pi over 6s. Now I'm going to do, just because there was the pi over 2 in there, I'm going to do stuff in terms of pi over 2s. So I've got, 1 pi over 2, 2 pi over 2s would be pi, 3 pi over 2, 4 pi over 2 would be 2 pi. But I'm going to get this thing started, sine curve, right here. And the period we said is pi. So from here I'm going to move over pi. Well, moving over pi, 1 pi over 2, 2 pi over 2s is pi. So I'm ending right here. Right? This one has from minus pi over 2 to plus pi over 2. like just what I did there. I get started and ended at the same time. That is, the shift tells me where to start. The period tells me how far to move over from that starting point to get to the ending point. Then, because it's a sine curve, I know I'm in the middle here, would be another point. Because it's upside down, I know the 1/4 point should be down the amplitude, so whatever that is, down 4. And up 4 at the 3/4 point. So down, down. The period tells me how far to move from my starting point to wherever my ending point is. Okay. Now looking at number 51, he said you got everything but the period. Well, the period, I see this starts at minus pi over 3 and ends at 2 pi over 3. So if I look at the difference between those two, if I take 2 pi over 3 and I subtract negative pi over 3, I get a total of 3 pi over 3, which is just pi. So the period here is pi. Now, they're asking you to come up with the formula for either this or that. This looks to me like an upside down cosine curve because I'm starting at the bottom and ending at the bottom. So I'm going to use this cosine. So I've got y equals, you said you got the amplitude okay. The amplitude is a half, actually it's upside down, so minus a half cosine. The x minus b, right? X minus the shift is minus pi over 3, so it's x plus pi over 3. And then the amplitude is pi. Now the k that they're using in here, k, remember we get the period as 2 pi divided by k. Period equals 2 pi divided by k. So if I multiply both sides by k, I get k times the period equals 2 pi. So then I'm going to divide by the period, and k equals 2 pi divided by the period. So the number that I need to put into the formula is not just the period, it's 2 pi divided by the period. So here the period is pi, so k is going to be 2 pi divided by pi, which is just 2. And so that's going to be a 2 right there. Okay. So the period's pi, which means the multiplier in here is a 2. Your standard period of 2 pi has been shrunk by a factor of 2, and hence the 2 right in there. Okay. Let's take a look at 53 on the next page, because again, you said you got everything except for the period here. Well, it looks to me on this one, you go from minus a half to 1. So, let me get a piece of paper. So from minus a half to 1, if I do 1 minus a half, that would be 3/2. The period is 3/2. So again, that k that I'm going to need, k is going to be 2 pi divided by my period. But the period here is 3/2. So dividing by a fraction, I'm going to multiply by the reciprocal. So this is 2 pi times 2 over 3, so I've got 4 pi over 3. In this case, the k that I need is 4 pi over 3. This looks like a sine curve. Amplitude 4. Shifted pi over, no, just 1/2. And then the k that I need to get the right period is 4 pi over 3, because I need the period to be 3/2, right? Notice that if I take 4 pi over 3, no, it's supposed to be 2 pi divided by b. So if I take 2 pi and I divide it by 4 pi over 3, that would be 2 pi times 3 over 4 pi. The pi's cancel out. The 2 and the 4 cancel out, leaving a 2. That would be 3/2, which is the period we wanted. So to get a period of 1.5, I've got to have a 4 pi over 3 right in there. Okay. And you got a couple more that you wanted to look at. Yeah, in 55 to 61 here, they give you some really big numbers or really small numbers, just because they're going to check your looking at the viewing rectangles. So, that first one, cosine of 100x. So the period here is 2 pi divided by 100, which would be pi over 50, which is pretty small, right? Pi divided by 50 is, well, it's like 3 divided by 50. So to do one cycle, it's going to be, really short. That one cycle is from 0 to pi divided by 50. You type that into calculator to see what it is. They say find the viewing rectangle, right? So how much of the graph do you want to view? If you want to do one cycle, you're going to go from 0 to whatever the period is. Well, the period is 2 pi divided by 100. Likewise, in 57, we've got the sine of x over 40. So sine of it's the same as sine of 1 over 40 times x. So the period is going to be 2 pi divided by 1 over 40, but when you divide by 1 over 40, you're multiplying by 40 over 1, which is 80 pi. Now that's pretty big. That's like 3 times 80. That's a big number. So so your viewing rectangle is going to have a lot of values of x, but still it's a sine curve. One cycle is going to be all the way out to 0 to 80 pi. 40 pi would be right in the middle, 20 pi would be the high point, 60 pi would be the low point there. 59 and 61, we'll know a bit more about the tangent in the next section, but the tangent repeats more often than the sine and the cosine curve does. Where the sine curve does one cycle from 0 to 2 pi, the tangent curve does one cycle from 0 to pi, and then does it again from 0 to 2 pi. The next section really deals a lot with tangent. So tangent of 25x, where the normal tangent has period pi, if you squeeze it by a factor of 25, now you've got a period of pi over 25. Right? And likewise, sine squared, with the sine curve going up and down from 0 to 1 to minus 1, when you square it, so there's the regular sine curve when I square it. The thing is, 0 squared is still 0. So wherever it's 0, and 1 squared is still 1, but minus 1 squared is also 1. So the sine squared goes up and down like this. From 0 to 2 pi, it actually repeats, where sine curve repeats once between 0 and 2 pi. The sine squared repeats twice. So it's like tangent in that its period is only pi. So sine of 20x would have a period of pi divided by 20. There you go. I hope that helped.